Algebra 2, Parent Functions and Transformations. In this concept, we're going to talk about equations or different types of functions. A function in math is just where two variables are in a math relationship with each other. So look at your notes and let's fill out the table. So in the very first row of your table, you're going to write down the four type of functions that we're going to talk about in this table. So across the top, write down constant, and then in function form is the most basic equation of a constant function. You can think of f of x as y. And then linear, f of x or y equals x. Absolute value, f of x or y equals the absolute value of x. And then quadratic, f of x or y equals x squared. Now remember, as I give the notes, that you can pause the video at any point in time to catch up and fill things in the table. Let's take a look at the graph of these parent or most basic form of these different functions. And then sketch these in your chart. So the graph of a constant function will look like this. Draw yourself an xy axis. And then if you go to where y is 1, you can just create that on your table, or sorry, on your axes, then it's just a horizontal line. So no matter what x is, notice that the y values just hold right where 1 is. Now the graph of the most basic linear function of f of x or y equals x looks like this. So we've got our xy axes, and then you've got a line that diagonally cuts right through the middle and goes through the origin. In that function, x equals y, so you can see we have a point where x is 1 and y is 1, where x is -1 and y is -1. So that's the graph of the most basic linear function. Notice also that this graph passes through the origin. Now sorry, that's my dog. Graph of the most basic or parent absolute value function is a V-shaped graph. So you're not going to have any curve in this graph. It's going to look like a line coming in diagonally that's going to kind of ricochet or bounce off in the opposite direction. It hits the origin, and then if x is 1, y is +1. If x is -1, y is still +1. So from the vertex, the very crux of the V, you're going to go up 1 over 1 in both directions. And then finally, the graph of the most basic or parent quadratic function is a U-shaped graph. So this is the equation y equals x squared. Notice that this is a smooth curve. It passes through the origin, and if you plug in 1 and square it, you get 1, -1 squared, you get -1. So this is where the points that create this curve come from. In the next row down, we're going to talk about how to transform these equations and these graphs. So what happens to the equations when you add values and how it shifts the graph. So first of all, in the row where it says transformation and the certain type of transformation where it says translation, left, right, just put an X through the square underneath constant and linear, because these type of translations or these translations do not affect the constant or the linear functions. Now in the square underneath absolute value, first of all, in that one square, write in this function, f of x equals x minus h. So whenever you subtract a value, and remember, if you subtract a value, a positive value, it's going to look like maybe x minus 4. But if you subtract a negative, it will end up looking like a positive. So that is going to shift the graph. In this case, it's going to shift the graph left or right. And so if it's added, it's going to shift the graph to the left. 4. Now underneath quadratic, write down first in general what it's going to look like. See how the h value, which is a number, is right inside the parentheses of the quadratic. Just like with the absolute value, it's inside the absolute value bars. So an example that you can write underneath it is x minus 5. This will actually shift the graph right 5. Go down to the next row in your table, and we're going to talk about a type of transformation which is a vertical translation. So how to move the graph up or down. This is going to apply to all of the parent functions. So underneath, or in the square, underneath the constant function row, now we're going to look at the next row down. So transformations, and these are translations. So we're going to translate the graph up and down. And it applies to all 4 types of functions. So underneath constant, you're going to write f of x equals 1 plus k. And remember, k stands for a number value. So when you add a value, so in this case, we added 4, and we get f of x equals 5, that shifts the graph up. So this example, it goes up 4. Now, go to the next square under your linear function. F of x equals x, so that's the most basic linear equation, plus k. So notice it's added at the end. Or you can subtract. It's like adding a negative. So in the example, f of x equals x minus 2. The 2 is at the end of the equation, so it's going to move the graph down 2. Keep going to absolute value. So it looks like this when you're shifting the graph up or down. F of x equals absolute value of x, and then outside the absolute value you're going to add or subtract a number. If a number is added, then it's going to shift up that amount. So this graph will go up 3. Now under the quadratic column, f of x equals x squared plus k. So just like the absolute value, notice the k is added at the end, not in by the x. Here, write this example down, f of x equals x squared minus 3. So here it's like adding a negative or subtracting. So when you see a number subtracted at the end, it's going to move the graph down 3. Our next row deals with when graphs are reflected over the y-axis. So that means if you think of the x and y axis, that all the points that were over here on the positive x side are now reflected or flipped over there. So it's going across, reflecting across the y-axis. Put an x in the box by constant because that's not applicable to the constant function. Now across the top of the rest of the boxes of linear, absolute value, and quadratic, write these words because this applies for all of those 3 functions. To create a reflection over the x-axis, you're going to multiply the input only, which is the x, by -1, because we want our x's that were positive to now become negative, so that the graph flips over to the other side. So across the top, write that instructions to multiply the input only, which is the x value, by -1. Now in the linear column, for reflection over the y-axis, write this example. So you have the line f of x equals 2x plus 3. To create a y-axis reflection, all you need to do is multiply the x only. And so right now the x was positive 2. Notice that it is negative 2 because it has been multiplied by -1. The 3 was not affected, only the number by the x value. So this is a y-axis reflection. There we go. Now keep moving to your next box underneath in the absolute value column and write this example. So let's say you start with the absolute value equation, f of x equals the absolute value of x plus 2. So to reflect that across the y-axis, you're going to simply multiply the x by -1. So that makes it just simply negative x plus 2. And then finally, for a quadratic function, same thing. So write down this beginning equation, f of x equals x minus 5 squared. To create a y-axis reflection, notice that the -1 has just been multiplied by the x. Nothing else is affected. Now the more common type of reflections is in the next row down, which is a reflection over the x-axis. So what that looks like is that if you have a graph, I'll draw my xy axis, then the points that were positives up here, y values, now are reflected so down below, so across the x-axis. So this applies to all 4 types of functions: constant, linear, absolute value, and quadratic. So across the top of all those 4 boxes, write this phrase. You're going to multiply the entire output, everything y or f of x equals, by -1. Now here's what it looks like for a constant function. So put this in the box that's in the constant value or the constant function column. So if we start out with a constant function of f of x equals -1, then we multiply it, everything that f of x equals, by -1, we get f of x equals +1, and that will flip it over the x-axis. For a linear function, if we start with f of x equals 2x plus 3 and multiply everything that f of x equals by -1, we will end up with f of x equals -2x minus 3. The entire line is flipped over the x-axis. With our absolute value function, we're going to do the same thing. So here's a very simple example. If f of x equals the absolute value of x, then we just multiply the output by -1, and this is what we get. F of x equals negative absolute value of x. Here's a more complex example. If f of x equals the absolute value of x plus 2 minus 5, and we multiply all of that by -1, then we get this new function. Notice that the negative is on the outside of the absolute value, and the sign of the 5 changed because we had to multiply both of those terms in our equation by -1. And then finally, for quadratic, a very simple example is just multiplying the parent function by -1. And then a more complex example is f of x equals x plus 2 squared minus 5. And then if we multiply all of that by -1, we end up with negative x plus 2 squared plus 5. All right, lastly, the last row, we can have a stretch or a compress. So if you have a stretch, then your graph is going to get steeper or skinnier. If you have a compression, your graph gets flatter or wider. So right now, this is not applicable to the constant function, so just put an X through that box and then move to the linear. Now, when we're talking about A values, that is the number that's going to be right in front of the X. So in your A value box, write f of x equals AX. And then we have 2 examples. So if A is greater than 1, this is a stretch, like f of x equals 2x. If your A value is less than 1, this is a compress. Now across the top of those boxes, you can write these directions because it applies to all of those 3 functions, linear, absolute value, and quadratic. if that a value, so the number in front of the input of x, is greater than 1, then you're going to have a stretch, and your graph will be steeper or skinnier than the parent. If the a value is less than 1, but not 0, then the compression is flatter or wider. Now for absolute value, and I lost my titles here, but I'll just write them in. So go to your absolute value box. So f of x equals a times the absolute value of x. So here is an example of a stretch by 2, because notice the a value has changed from just 1 to 2. And so it's a stretch, and then this one is a compression because it is less than 1. So this V-shaped graph is going to be skinnier than the parent, and the last one is going to be wider. This is just the same for quadratic. So in your quadratic box in that column, f of x equals a times x squared. If the a value changes to a number that's greater than 1, like 2, this is going to be a stretch. That U-shaped graph will be skinnier. And if it's a fractional amount, the U-shaped graph will be wider. It's a compression. All right, in the next set of notes, we're going to work with now some equations and actually try and figure out the transformations that have happened, and then look at some transformations and write some equations.